All right, guys. Good afternoon and welcome back to our normal programming. Today we're going to just solve. We're going to solve question one from problem set three using MATLAB and SIMULINK. Um, since we already understand how to solve the questions analytically, we'll just jump straight into the um, software solutions. So we'll first start by just going over the question to understand exactly what's going on. Then from there, we'll jump into our analytical solution and use that to develop our MATLAB um, code. Then from the MATLAB, we'll go into Simulink. Is that right?
Yes,
Precious.
yes, yes.
Okay. So I'll be with Precious along the way to ask him any question that, because he understands what's going on, he might skip a few steps. So, but I'll be with him along every step of the way to make sure um, he doesn't jump too much. So, Precious, are you ready?
Yes, I'm ready.
Okay. So, he's just clearing the command window before we start and checking if his code is good. So, guys, you can just, this is not really important right now. We're just making sure everything is good. When we come back here, we'll explain exactly what's going on. But for now, let's just chill. So, I'm ready where you are.
Okay. Okay.
Is it good? Okay. So, we'll just go jump into the question itself. Now, the question, like I said before, is from problem set three, and the question is number one. That's V, part V of number one, which says you should develop the dynamic model of the decision column in Simulink. Now, Precious, how do we start? I think I have an idea that we have to first from the analytical solution or from our developed equations. That where we start from.
Yes, we have to develop our equation, like derive the dynamic equation before proceeding. And here they've helped us to derive the dynamic equation by our they've helped us to derive the dynamic equation of the distillation column. Sorry. Oh. Okay, so sorry.
Okay, apologies for that. I'm presenting now.
Okay, so we are trying to develop the dynamic model of distillation column in Simulink, but first we are going to use MATLAB first, then use Simulink at the other end. So that's how we are going to do it. So when we want to develop like dynamic model like this, we'll try to get the solution, like the equation, where we get equation that is solvable that has three unknowns and three three unknowns and three functions. That's like this. That's dx1 over dt is equals to 1 over md vr, as you can see it for the overhead receiver for the feed stage
So I
and
think
for the
first
boiler.
of all we need to first develop the questions for each
Yeah,
step
we
of
need to first derive the equations. We need
before
to first,
doing MATLAB.
yes, we need to first derive the equation. It is MATLAB. MATLAB is just used to solve the equation. Yeah, we
So
need to
we
first derive the equation. When we derive the equation, then we can now use MATLAB to solve to get our solution, to get the solution of x1, x2, and x3.
so that's the goal here. We're looking for
Yes,
X1, X2.
yeah, we're looking for x1, x2, and x3. So in this case, we're going to use an OD45 solver. OD45, like it means I would like to refer to the documentation of MATLAB as described here. So sorry, the MATLAB documentation. We are trying to use OD45 solver. Sorry, I'm coming.
Okay. So you can open the documentation anytime.
Yes, you can open the document once you hear of any term in MATLAB. Most times, the documentation is resourceful. Like the documentation is fully loaded and
Okay, so
does yeah, it helps in any way. And there are examples under each equations. Like, how to use the OD45 to solve a particular equation, entering the time constant and the initial value of the integrator and the initial value of the output. That's how it is. So in this case, you solve non-Steve differential equation, medium order method. So they said OD45, this OD45 that you can see here, this OD45 you solve and then you open it. It's like a function. It's like a function that has been made, you get, inside, like that has been made inside MATLAB. It's just like a library that has been made. Like people that are vast in programming already know what library means. So it's just like a library. It's just like a function, yes, I made that you can call anytime. When you call anytime, you put like there's some set of input it accepts. It accepts a function, it accepts the time span, and it accepts the initial value of the output. You get? When when you provide that, then these are the outputs it will give to you. It will give you the time range and the final output. That's what it gives. Where the time span is T naught and TF. That's like the initial time and the final time. Integrates the system of differential equations. Differential equation of y prime is equals to function when f is equals to function of t and y from t naught to tf with initial conditions y naught. Each row in the solution array y recommends to a value returned in column vector t. It will return the answer in a column vector. That's what he's just trying to say here. It's going to return the answers we are going to get. Our output is going to return it in a column vector.
So the vector we used to write.
Yes, that's one is row times column. That's 1:3. If it's three equation, it will be 1:3. If it's two equation, if it's two unknowns and two equations, it will be 1:2. But in this case, I think MATLAB always output the column first, then the row second.
So column first.
Yes. Column first, then row. That's how it does. Then
I think things are still a little confusing, but when we go to MATLAB, we should be able to understand what
okay, yeah, you should be able to understand. So this is our equation that has already been typed. First of all, we are creating a function of x dot that will give us x dot. In MATLAB functions, when you're trying to create a function, the output is always at this side of the equation. It's always the s dot, as you can see here. This is the output. Then just the way the OD45, just the way I explained the OD45, having to accept a particular input. You get this dy function. This is a name. We gave it a name. We gave it a name, dy function, which accepts the time as an input, and it accepts x an input itself. So we create a function. We create a function using that equation, using this particular equation.
So let me ask a question. That means when we define this is a function, this is the output.
Yes.
X dot is the output.
Yes.
Then what is in the out? Like this is our equation. This x dot equals to d for function t of x. So basically, the
Yes,
function
it's function of t and t of x. That's how it is.
So that means if we have more than time and input variable, we can also like add more stuff. Or is it just does it only accept two?
It depends. A function is when a function is created, you make it to do like what you want it to do. Maybe you want to do maybe a plus b. You get a plus b. So it will accept two inputs like that. That's a and b. That's how it's meant to be. So in this case, it accepts t and x because you need the t as an input, you need the x as an input. That's how it is.
So this part here, you are just commenting.
We are defining the parameters. We comment. This is the comments. When you want to comment in MATLAB, you just need to put like a percentage in front. And when you want to create a divide row, you can just create it to section it somehow.
So you can understand exactly.
Yes. Like this line, like maybe you section this line. If you want to do it again, you section this line again. sorry, to section this line again. So it will divide it down.
Readability,
Yeah, it will to improve readability so that the person will understand, the person you are trying to pass it to, you will understand what's going on. Like this is another section, this is another section, this is another section. That's how it is.
So can we just take it from the
So the defining parameters, we are trying to define our parameters, the parameters needed in the equation that are used in the equation. Like, sorry, sorry, yeah. So these are the this is the equation we are trying to solve. It's a dynamic equation of a distillation column. We've already derived our equation. Is dx1 over dt is equals to 1 over nd vr over y2 minus x1, like that for the overhead receiver and for the feed stage for the boiler. That's what we are trying to solve, and we have some values that have been stated, like alpha is equals to 5, r is equals to 3 mole, then qf is equals to 1, f is equals to 1, d is equals to 0.5. So all those parameters, we are going to state them, we are going to give them to MATLAB. So that when we start typing our equation, it will know that, oh, this is what I'm meant to pick. If I want to pick, if I'm trying to get the values of alpha.
So we just need to define everything.
Yeah, we just need to define everything. When you,
We've calculated already. and
yes,
everything has
yes.
been put.
Yeah, we should
Interrupt. Okay, so yeah, this was and also see that this one didn't you calculate?
yes, it's because we are inside the equation, like we are using the b inside the equation.
Okay,
So we don't want to, like, we don't want to show how it was gotten.
okay, but okay, I understand.
So we are just trying to show how it was gotten. Then b is equals to f minus d,
Okay,
lr is equals to r.
that's from here.
Yes, yes, yes. B is
But
equals to
all
f
these
minus
things
d.
we solve them analytically, but now we want to solve them.
Yes, yes, yes.
Continue, my professor.
So vr equals to r plus d, then ls is equals to lr
So for anyone,
plus,
the unknowns, we state their equations
yes, the unknowns. We state their values.
for the value.
When you declare a value, you assign you assign a variable, just like assigning a variable.
Okay, but
Like that, you define your parameters, like that.
I see.
But from the normal course, like we have input, we have output, we have parameters,
Yes.
like coefficients. Yeah, so these are the parameters. We define our parameters. Then md is the parameter, mt is a parameter, mb is a parameter. Then all other ones are parameters, like that. So when to calculate the equilibrium vapor composition, that means y2, because we are going to need y2 inside the equation. So they try to, like, look through, like, iterate through a particular equation, because it did not want to, like, start typing the same thing all over again 3 times. Imagine, sorry, let me do, just imagine doing this. Just imagine doing this. Imagine doing this, changing the values
Every time.
every time.
Okay, that's not sexy.
It's not advisable.
It's work, but it's just a lot
Yeah,
of
it's work, but it's just like
stress.
yeah, code for dummies. That's how it is. Imagine something like this. So that was what he was trying to shorten. So he created. Can I? Okay, I can go back. Okay. So what he tried to do, he tried to create he tried to create a loop that iterates from when, for, like, when I is equals to 1 to 3, Then you now put the index inside where you are meant to get all those index like 1, 2, 3. Like maybe when I is equals to 3, when I is equals to 1,
Okay, I see.
this
Then
IA will be 1, this IA will be 1, this IA will be 1. When I is equals to 2, when I is equals to 2, this one A will be 2, this one A will be 2, this one A will also be 2.
so it's like
When I is equals to 3,
what we do with Python parts.
with Python in part 2, just like iterating through a particular equation with an index, you iterate through.
Okay, but I have a question. Yeah. So this code here, this one here, this part, where did we get this equation from? Is it from the question or
Yeah, it was on the question. We are trying to calculate the equilibrium vapor composition
okay,
of the column of the distillation column
okay,
because we are going to need it now in our equation.
okay,
Sorry.
okay.
We are going to be I don't think the solution is not written here. So we are going to be naming it in our equation like because there's y2 is present, y3 is present. I don't think y1 is not needed. This y2 is y2. There's another y2 here. So they are needed in the equation.
Okay, so basically, our equations that we developed already was just to determine exactly what we need to define in our code, right?
I don't know. Can you come again
So,
about the question?
for example, now look at this. Because I realized there was Y2, that's why I
Hmm.
figured out a way to find Y2 in my code.
Yes.
I noticed that there was MDU, I declared it.
You declared it.
I noticed that there was BR in my code too. That's why I also went here, I
Yes.
declared it as well.
Yes.
So,
So we are just trying to solve a particular equation. We are just trying to like provide values for it
so,
so that it will be solvable.
so MATLAB needs to have all the values.
It needs to have all the values for this problem, for this kind of problem. It needs to have all the values.
So, you can't just proceed. You have to have all the values in the equation,
Yes.
declare them. Okay, I think I understand what
Yeah.
you're
You
saying.
declare them. Then when you declare them, you write the equations. Then you solve them. You use a solver to solve them.
So, just to recap, first of all, we started from defining or creating a function.
Yes. We created a function.
Then we defined all our parameters.
Yes.
Then
Create a
this,
function with an input that has an output, an input that gives an output.
okay, with an input and with an output. Then
Yeah.
define our parameters.
Define the parameters. Then
Then also calculate the equilibrium vapor condition because this is also a part of our
yes,
parameters.
because this is also a part of the parameters needed to solve the equation.
So imagine we already had this, we don't need to calculate.
Yes. We don't need to calculate. Imagine we already have an answer for this. We don't need to calculate.
So because you don't.
Yes, we'll calculate.
Then after that, you now define the steady state functions.
Yes, we define the steady state functions.
Okay.
Then you can see here what you did there was to put them in a vector form.
Hmm.
You put the equation in a vector form.
Okay.
As you can see here, the x dot here at this last part
Okay. I like. I see. Okay, so our answer will be
in a vector form.
wow. Okay. So this
So
first
that
one,
the output of this equation will be in a vector form. It will
but
give because of the solver we are trying to use. It will accept it in a vector form.
okay. So this one
The
is just make
output.
sure it gives us.
Yes.
So just to recap this piece, these three equations, x dot one, x dot two, x dot three rather, are from here,
Yes.
right?
That from this equation is for the one is for the feed stage, one is for the reboiler, and one is for the
Overhead receiver.
overhead receiver.
Okay. So we also need to be careful of naming conventions. We're not gonna put x1 for x2 and
Yes.
I think I understand what's going on. So that's basically what we do.
Yeah, that's basically what we are trying to do, and this is where we put our solver,
Okay. So
defining an initial conditions of 0.5. We have three outputs, like three unknowns.
mhm.
We are going to have three initial conditions. So that means it has been 0, 0.5, and 0.
Okay.
And
So
we,
so
we declared a so
so
you are
before
trying to
before you move forward,
Mhm.
these are our initial conditions. Do we okay. So I think maybe later we'll explore that. But when I just know that initial condition used in this code
Yes,
0, 0.5, and 0.
yes,
So
yes,
for
yes.
this for each step, right? Or for each x1, x2, x3.
just for each of the three unknowns,
Okay.
we have an initial condition for it. It will be used to on Simulink
Okay.
inside the integrator. But let's leave that for now. Right?
You,
So we declared a variable called function that's pointing to the our M file here. That's pointing to our M file here because they're in the same file. It's pointing to this particular function here, like this particular function that we have stated. I told you the way I told you OD45 accept three inputs. I'll be sometimes it might be two, sometimes three. You accept three. This time we are using three. The way you saw it in the documentation. This time we are using three. So we have an output. So we are trying to like use the function, these OD45 functions. OD45, then the accept function, our variable that has already been declared. This function has already been declared here
dynamic function.
as dynamic function. That's already yes. This art is just pointing to this function.
Which is this, right?
Yes,
This
yes,
last three. Sorry, I know I like something more. This X dot and okay.
yes. All these S dots.
Okay, that's what it's pointing to.
It's pointing to this O file.
It's not just
You get this O function. It's pointing to the O function.
so if you calculate everything by
Yes,
itself.
it's calculate everything by itself.
Okay.
It has already been made. It's like a library that has already been like it's there already.
Okay.
So it's just calculate everything that is there.
Okay.
So it accepts like the time span, the initial time and the final time. Then it accepts the the initial conditions here.
Okay. So that means
So
for OD45,
yes, let me try
it
to
wants to
let me try to check. Let me try to show everybody inside the documentation.
inside the say exactly what it
Yes, yes, yes. So OD OD45 accepts uh, a function, then it accepts the time span and initial conditions. This OD font is a function, is a one is a just the way it was stated here. That has time span of 0 and 500. This is the initial time and this is the final time. And this is the initial conditions as it was here. Then we are trying to plot our graph here. We are trying to plot our graph.
okay. So just to confirm, um, for this OD45, this function points to this function here, which is actually points to the function already
Yes,
developed.
we've already developed here.
From here to here is our time span.
Yes.
From 0 seconds to, or is it in seconds or milliseconds?
Seconds.
Okay, from 0 to 500 seconds.
No. Milliseconds, sir.
Okay, 0 to
Okay.
500 milliseconds.
Yeah.
And then this one points, this X not here points to this function, another um, variable that we declared.
Yes, yes.
Okay. So you now ask um, MATLAB to plot the value of t.
The value of t against x, against our inputs,
Okay, so it's not
to shows when it's set to when it's in steady state.
Oh, interesting.
Just to show when the equation reaches steady state, like steady value.
So that means this part here you can increase it if it
Yes,
doesn't
you can
reach
increase it if it doesn't reach
steady
the
state.
steady state yet.
But we always start small.
Yeah.
So I think I get it. So after we've done everything, this just gives us our t of x, plotting values of t and x. Then we just plot.
We plot that values gotten from there.
So how do we plot it? What do we do? What do
So when you are trying to plot, you just click on this green button.
we run?
Having this opened, you get stating that you are trying to like run this. If you are trying to, it will show you that it will show you what you are trying to run. Can you see there?
Yeah.
It will show you what you are trying to run. Then if you go here, it won't run at all.
Okay, because
It won't run. There's no solver. You are not on the page of the solver. Yeah. So when you press,
Ooh,
it
very
plots
nice.
the graph, then yeah, as you can see, this
So you
is
can click to see.
the result.
Okay.
Hold on,
Oh, it
sorry.
even gives us our exact. Oh, that's very nice.
So it shows all the values, you just input in the graphs.
Okay. That's yours 500 values, right? It's even more than that.
It's more than that.
All the values within each. Okay, for as long as you keep swiping.
Yes, it's based on the time. It's not based on columns.
Okay.
I think this is error. So you can see at some point, it stayed at a particular value.
Oh, that's when you reach steady state.
Yes, yes.
So the value
That's
is
what,
not really be changing much.
yes, yes. It's not changed.
Look at this side, folk.
It's 0.1789. This these ones are still changing. But this is
The first column.
0.8211. Yes. Ignoring the second part. So
But it's even changing. It's not even by a lot. It's like 0.4786, 4789. It's not really changing.
yeah, it will reach the
But it's reach a point, yeah.
yeah, where everything will be the same thing. The same thing. Over. The same thing.
Might take some time to reach it.
Yeah.
Okay.
It's when everything reaches the same thing.
Okay, so
And
to
when the
stop.
time stopped,
Oh,
this particularly when the time stopped.
wow.
Can you see? This is 0.4787, this is 0.47, this is another 0.4787,
So it's
this is
not
another 0.4787. It's just on the same,
yeah, around the same area.
around the same area. So you can see the graph here. So, you can see the graph here. This is where I think this is x1,
Okay.
this is x2, I think this is s3.
How do you know which one is which?
We can name the graphs, like we can name it. We can assign a legend to show us which one is which one.
Okay. And how do you do that? Let us show me how you can do that.
Okay. Okay, I'm coming. Sorry. Can you
Okay,
sorry.
so just give us a second and we'll get back to it. So just 2 minutes, I'll get back. Okay, guys, we apologize for um, the break. That was very unfortunate. We had a few technical difficulties, but let's start sharing our screen now so we can get back to it. Now, before we had some the unfortunate difficulty, I was asking Precious how to add legend to our plot so that we can easily identify what belongs to what and, straight from the graph. So, Precious, we continue.
Okay, thank you. So sorry for that. So we want to try to add legend to this particular. Sorry, let me run it again. This particular graph. So we are trying to add a legend to it so that it to show. So I can easily recognize which one is which is which is which is which. So I'm going to try and create it. This one. X2, as you can see, is like giving me X3. So that's that. Okay. Okay, as
Oh,
you can see
wow.
now,
So, that's very
this
straightforward.
is X1 and blue. It shows that the blue one is X1, the red one is X2, and
The
the
yellow one
yellow one
is
is
X3.
X3.
So that's very straightforward.
Yes, yes, yes.
Just to easily recognize it.
Yes,
Thank,
just to easily recognize the.
okay, thank you so much for that. So that means we've already been able to create a graph and be able to determine at what point exactly
Yes.
these x1, x2, x3 become steady state,
Okay.
right?
Yes,
Because
yes,
you can just move this here to identify it, right?
yes.
Okay, I think that's very nice. Okay. So what's the next step?
The next step is to go to Simulink and simulate and show a block diagram of this particular equation and solve and get the block diagram of this particular equation
Okay,
for these equations.
okay. So that's what we're trying to do.
Let me show them the mark graph. Alright. Okay. So we want to try and simulate this particular
The x1, the x2,
equation
the x3.
dx1, dx2, dx3 so we can get our values
All right.
and get it back.
Let's jump into it.
Okay.
So we start out by opening
Opening
Simulink,
the Simulink.
initializing. Okay. So sorry, can we just make it full screen? Thank you. So we create a model, blank model,
Yes.
just like you explained in the last class.
Yeah.
So basically, this thing is intuitive. It's not as if you are just copying and pasting code. You are
No.
looking at exactly what's going on.
Yes. Yes.
So the question that will determine exactly what code you come up with. So
Yes.
basically, with more practice, the better one will get.
Yes. Yes. I don't know why it's taking so long.
Especially in the net. Okay.
Okay, so this is our blank model.
Still
As
loading.
created, yes. And we are trying to simulate this. We are trying to simulate this equation,
The
don't forget.
x1, the
Yeah.
x2. Right.
So this is the library browser. You can use if you want to bring it's like the Simulink is like a block diagram the way I explained it the last time. So we can bring out the library browser. We can bring out this library browser and search for whatever we want to use. Three questions. I'm trying to solve three questions with three unknowns. So I want to get the result for three unknowns. So I want to get an output block. I'll just type output. Sorry. output. I can just put it there. This is an output block. I'll just drag it to a blank model. Then if I want to create a copy of other ones, I can just right click and drag. If I want to create another one, because I'm looking for three outputs. So I can just tap and drag again. Then when I tap like that and drag again, then probably you can use these, or you can just double click on a blank page. You search for your block, see if you know the particular name of the block. Then the next thing I want to use is to use an integrator. The way I explained this equation the last time was that this has been differentiated. But what we are looking for, this particular equation, they've been differentiated. But what we are trying to look for is we are trying to look for x1, x2, x3. So if we want to get the x1, x2, x3, we need to accept and we need to integrate it. You get? So we integrate this particular equation. We put this particular equation, we put the blocks inside an integrator with the particular initial conditions to get this x1 back. We are just trying to get this x1 back to get like just the way the OD is over. We are just trying to like create a block diagram of this equation, then pass it inside an integrator with an initial condition, then get our values. That's what we are trying to do. So I'm trying to like I will double click, then search for integrator. When I search for integrator, it will let us know our integrator. And if I want to input just let's consider. So if I want to like if I want to put three integrators, then I'll just tap and drag, right click and drag, right click again and drag it. If I right click, it creates like MATLAB has they've done it there so that it will just once we tap and drag, it will create a copy of itself. So then we join this again. Then the way I explained, we are trying to like get x1. So this particular line give x1. So you can change the output here. Sorry, you can change the particular output here. This one to x1, then this to x2, and this again to x3. Then the equation. What's the first thing in the equation? After we we signify our x1 and created an operator, then what is left is to do a block diagram of this particular equation. Can you see the mouse? This particular equation. So what is the next thing? We will try to we are going to first thing first, we are trying to divide MD by VR into bracket y minus x1. So first thing we need is a division block. In this case, we need the division block to divide this MD with this equation, with this particular equation. So that's the first thing we are going to be needing. So I will tap again, then bring out the division block. So divide. Sorry, sorry for that. Math operation. Sorry. Sorry, I don't know why it's loading. Okay, so this is our division block. Then I think that's the same thing we'll do for equation one. That's the same thing we'll do for equation two. That's the same thing we'll do for equation three. We are going to divide MD by what we have in equation one. Divide MT by what we have in equation two. divide NB by what you have in equation 3. So I think we are going to create another copy. You create a copy. When you want to create a copy, you right click then drag. Right click then drag. So that's how it's going to be. Then sometimes when you place it on the same line, to show you we are trying to connect. Can do it in that same way. So what is next? What is next is that we are trying to like multiply VR. We've already done this MD. So we can just bring a constant block to signify MD. A constant block is used to input value, like just like we are creating a variable. So constant. So constant block, it has a constant value of when you want to bring out this particular box, you can just double click. You double click on the column, you double click on the box. Sorry. So if you want to change the value, you just delete this, then put 2. Immediately changes. So this we have to rename this to MD. When you rename it to MD, then you connect it to we are trying to divide. We are trying to divide by VR. So we connect it to the division. Here, when you want to open this up to the division block, you double click to input. Probably you want if you want to multiply, you just change this to 2. It will change. It will change. Yeah. But when you are trying to divide, it will be an asterisk and a forward slash. I think forward slash. So when you apply, when you okay it to create a division block, then the next thing is to find what VR is. Like try to derive, try to create a block diagram for this particular part. This particular part. This particular as VR times multiplied by y2 minus x1. That means VR multiplied by y2 minus x1. That means first thing we need is a multiplication block, like a product block. They call it a dot. I think that's what they call it in MATLAB, dot. And we can use this particular block. This is a particular block that I'm talking to. You can turn it to a product block too. You can just drag it. You can just right click and drag. Then double tap. After double tapping, you can just change it. You can just change it to double asterisk, just to show that you want to multiply something. If you want to multiply, then you change the name to multiply. You're trying to multiply VR by y2 minus x1. So I think VR has been. I'm trying to check if VR is given. So VR is equals to R plus D. VR is equals to R plus D. So we are going to create another block for R plus. So we know that VR is equals to R plus D. So another constant block. You can just find another constant block. Constant block. This will be for R, and another block for D. Then R plus D. Then we'll bring an addition block. That's add. When you bring an addition block to add constant, you can see add constant here. Oh, sorry. Addition block. So the reason why I didn't use that was that like we are not adding a particular constant, we're adding D that has a varying value and R that has a varying value too. So connect the R to this. We are trying to plus them together, the R plus D. Then we connect it to the parts where we have our VR is meant to go to. Then we can name this line. Hey, sorry. We can name this particular line as VR. So that particular line will be named VR to let us know that, oh, this is the line VR going to multiply to this. Then what is next? Then oh, sorry. Then we are trying to multiply VR times y2 minus x1. So y2. And what is in our y2? I think this is the equation of y. This is how y is gotten. It's gotten from for the equation. So y2 is meant to be alpha times x1 divided by 1 plus alpha minus 1 times x2. Alpha times x2 divided by 1 plus alpha minus 1 times x2. So that's because we are trying to like here I explained the way we are trying to get it. We are trying to get our y2. You try to loop over like this particular equation. You try to loop over it so that we can actually get our so that we try to get our y2. If you need y1, you can get it. If you need y2, you can get it. If you need y3, it's already there. So we are going to look for a constant block. In this case, we are trying to like create a subsystem here. We use a subsystem because we don't want our MATLAB model to be messy and all like that. So we are going to create a subsystem. We are going to create a so to give you the shortcut of it, you can just click on it like tab, then press Ctrl G. When you press Ctrl G, you create a subsystem inside this particular this particular this particular SIMULINK model. You create a subsystem. You can name it y2. When you name it y2, when you go inside, as you can see, we've gone inside the y2 subsystem. Then what is inside y2? Y2 is equals to alpha times x1 divided by 1 plus alpha minus 1 times x2. That's first of all, we need alpha, and we need x1. And as you can know, alpha, sorry, I'm going to try to delete this. Then first thing first, to get this y2 output. First thing first, in this alpha, we are trying to divide 1 plus alpha minus 1 times x2 by, we are trying to divide alpha times x2 by 1 plus alpha minus 1 times x2. So that's what we are trying to divide by. So let's just put this alpha. This is alpha. These are alpha. Then I'm going to bring in an input because you're trying to get it. That's what we are trying to get. So we are going to bring in an input so that we can have an input here. So that we can have an input here and collect it from this. You know, this x1 is here. So we want to try and get this x1 inside this subsystem. So we are going to try and get an input. So as we're trying to get an input, then first let's go and get the the division block, that's divide. That's divide because we are trying to divide. We are trying to we are trying to divide alpha times x1 by so you understand. We are trying to divide this. We are trying to replicate this equation in terms of block diagram. So alpha times x2. Then here state here alpha times x2 as we are going to click and drag, right click and drag, then double click, then change the values inside, connect it to our multiplication because it's at the top, is the numerator. We are going to connect it to the top. Then this is x, this one will be an x2. So alpha times x2 as, as written here, it said alpha times x2. You can, for simplicity's sake, I think I should rewrite this so that you guys will understand. Um, one, one, one. Sorry, I'm trying to rewrite this. So this is what we are trying to use, y2. So this is exactly what we are trying to use. So this is what we are trying to do. So alpha times x2. So that's what I've done. After alpha times x2 divided by 1 plus alpha minus 1 times x2. So divided by alpha plus 1. The first equation is, that means addition. We are trying to do addition. We are trying to add 1 to alpha minus 1 times x2. So first thing first, we are going to our addition block. Then this add. Then this is 1. I'm going to change this to constant. Constant 1 plus alpha minus 1 times x2. Here we need a multiplication to multiply. We need a dot product. We need a product block to multiply x2 with alpha minus 1. As you can see, we need a dot product to multiply. So no, multiply. Sorry. No, I don't need again. Sorry, I don't know why it's not bringing it back. Oh, sorry. Sorry, I'm the one making mistakes. Sorry. No. Let me go to the right now. Yeah. So it's called product. sorry for that. Then we are trying to multiply x2 times alpha minus 1. So as you can, as we've known already, this is x2. So I'm just going to join this line. I don't want to create another, I don't want to bring out another input. So I'll just join it with this x2 like this. Then alpha minus 1, there's an alpha minus 1. So we are going to create a subtraction. I'm going to subtract again. Subtract, then sorry. So here we're going to alpha we are trying to do alpha minus 1 times x2. So it will be like you just connect it because you don't want to be creating, you don't want to go around creating blocks again, creating different blocks again. You don't want to go around minus 1. You can draw this out because this is 1, this is coming out. Then connect this to this as alpha. This, that means this alpha here minus 1. So this is a alpha here minus 1. Sorry. Alpha minus 1 times x2 here. So we're going to draw it x2 here times x2 here. That means alpha here. This is the alpha. Alpha minus 1 multiplied by x2 here. Can you see? It's going to x2 here. Times x2 here. Times x2. Alpha minus 1 times x2 plus this 1 here. So we are going to add it. This equation, this o, sorry, this o, sorry, this old equation here. We are going to add it to this 1. Like this. Let me point it again. This old equation here. We are going to add it to 1 here. So then divided by to divide the alpha times x2. This is alpha times x2. This particular line brings in after alpha times x2, and this particular line brings in 1 plus alpha minus 1 times x2. So this is our y2. Then when we move out here, we are going to when we move out here, that's our y2. That's our y2. When we move out here, I told you we are trying to bring in this x2 inside of here. So we just connect this x2. I'm just going to connect this. Sorry. I'm just going to connect this to here. I don't want to be confuse someone. I don't want to confuse someone. So I'll just to signify that is an output, just to signify that is an input. So I don't want it to confuse someone. Just signify as an output. Just signify as an input. It's going inside this particular equation, this particular block diagram. So what remains in our equation minus x1. That means I'm just going to our addition block, click and drag. Then here you can change the same way you can change the division. You can interchange between division and multiplication. The same way you can interchange between addition and subtraction. As plus and minus. We're trying to minus y2 here minus y2 here minus x1 here. No, we are integrating this particular equation. We're integrating it so that we can get x1 here. Sorry, we are integrating this particular equation. The way I explained, we are integrating this particular equation. We are integrating this particular equation so that when we integrate it, what we get at this other side will be x1. That's what we are trying to do here. Instead of having a differentiation at the other side, we are trying to get our x back. That's what we are trying to do here. So let me move this to the other side. Okay. Then we'll jump to the second one. We are trying to divide. Sorry. So for the second, we are trying to divide empty by this particular equation. We are trying to divide empty by this particular equation. So what we first need is our integrator. Then we are going to divide. Come here, let me arrange it very well. So we are going to divide empty by this particular. We are going to divide MD. This is the equation we are working on. Empty by this particular. We are going to use empty to divide. Use this to divide. Use empty to divide this LR x1. So yeah, I'm going to copy here, then change it to this is empty. Let me change the values to 1 and change the values to 1. Then we are inside the box already. Then the first thing first, the first thing we are going to do here is to know what we are adding together and what we are multiplying together. We'll go to addition. We'll have to add everything before we have to add everything before we multiply them. So we are going to add LRX1 plus VS Y3 plus F times Z ZF minus LS X2 minus VR Y2. Simulink is just like writing your equation like on paper, but this time around they are using a block to demonstrate, like to signify. So first thing first, we need an addition block. We need an addition block. We need an addition block, and we are going to count the amount of addition that we are trying to do, addition and subtraction we are trying to do. Like it will be like a coefficient. It will be like their coefficient in this case. Maybe plus 1 minus 1 plus 1 minus 1. So this is we have plus 1 here, plus, that means plus, then minus minus, that means 3 plus and 2 minus. That's why it's going to be. Then we'll double click, change it here, plus and minus minus. It becomes so as to know that we increase the input to 5 from 2. So that's what this we are trying to like we are trying to like uh, we are trying to like subtract, add some things and then subtract some things that had already been multiplied. So we are going to like LR times x1. That's what we are trying to do first. Then I think LR is equals to R. That means we join it LR. We are trying to do sorry. LR is equals to R. So we are trying to do LR times x1 first. We are trying to multiply them together. So dot. And this is our R. So we don't need to look for R. So the way we did in subsystem, we just connect it together, like connect it here and move it to the back. Sorry. LR is something as R. Probably I should just name the line. So LR times LR times x1 here. So this is x1. So we are going to take this like this, like this, like this, and join it here. It's the x1. So I'm here to connect this. So I'm going to connect this down. Then sorry, what I did there was VR, VR, VR times VR times y2 minus x1. I didn't connect that. Sorry, so sorry. I didn't connect that. That's VR. VR here, that's R plus D. Then time multiplied by y2. This is y2. This is our y2 minus x1. X1 here minus x1 here. Sorry. Minus the one that is going to x1 here. So I want to try and delete this. So here now, here is going to x1. Is going to x1. That means LR, we've completed LR. That means LR is same thing as R. LR is same thing as R. Then we are going to connect it to the first here, LR times x1. And we know that LR times LR is equals to R. This is same thing as R. So LR is same thing as R. And let me use a pipe notation. So LR. So we are going to LR. This is going to LR times x1. So we are going to connect to the first addition. Then the second one said VS minus VS times Y3. That means what's VS? VS is LS minus B. And LS is equals to LR plus F times QF. LS is equals to LR plus F times QF. So sorry, I'm just trying to remember. This is LS here, and this is VS. So here what we are trying to do is VS times Y3. So first thing first, we need to multiply. So drag on multiplication block here. Sorry, I didn't take it from here. I will take it from here. So VS as you know here, VS is equals to LS minus B, and LS is equals to LR plus FQF. The reason why I don't want to create the subsystem here is because some of these values are still going to be needed in other equations, in other part of the equation. So I'm not creating a subsystem here. Thank you. Subsystem is not. I don't think it's the constant. They need the constant block. To simplify it for QF. So this is LR plus F times QF. We are going to create an addition block. An addition block should be here. Sorry. So LA Y2, subsystem of Y2. This is subsystem of Y2. So LR plus F times QF. So this is LR. Sorry. So LR plus F times. So we need the multiplication block again. We need the product again. Then a constant block of F times QF. So it's basically this LR plus F times QF to give us LR here. This is going to LR. So this is going to LR plus LR plus sorry, plus F FA times QF here. So it's going to so we are trying to get this LS minus B. So it's going to here, it's going here minus. So this we name this as LS just to show it LS minus B, LS minus B, and this is LS minus. So this equation Vs times, we are still here, Vs times Y3. So we are going to create another subsystem of Y3. You can just double click and drag. Since it's basically the same thing, we just need to change the values. So we can just click and drag them. Change it to 3. Change it to 3. Then I think that's all. No, sorry. Y3. And that means Vs times Y3. These are Y3. Vx, and these are Vx times Y3. Then here, go here, it's here. Because this is our x3, so we are collecting an input here. We're collecting an input here, so it's going inside the subsystem as an input to complete this.
Yes.
Yes,
Yes, please.
yes.
Which one is it?
Huh? It's the second equation. Yes, this second equation. That's what I'm trying to do.
But we are still.
Yes, yes. So then put it. We'll plus it. We'll add it to our plus that's already been created.
Live stream ti parí lọ́wọ́.
Hey, mo ti sọ̀rọ̀ sí.
Don't worry, don't worry. I'll fix it.
What is it?
Sorry to interrupt you. So sorry guys for the cut in the presentation, but we're just going to continue. He has not skipped a lot, so we'll just keep going. So Peace has a question. Please, can you ask the question?
These are blocks signifying Y2, X2. They look different from other blocks.
Yes,
Why is that so?
I just to make the model look clear. So it's basically this. So I just created a separate model to simulate this. Then I then brought the x2, this particular x2. I brought this particular x2 inside this. As you can see, it acts as an input of x2. So inside this particular model, when I created this particular model.
So how were you able to? So how do you insert something like that?
So no. You just create right click then drag. Then for a shortcut, you can just press Ctrl G to create a subsystem, an empty subsystem. Ctrl G. Yeah, Ctrl G. Just create an empty subsystem.
So that you simplify your model.
Yes, so that it's simplify to make it readable, more readable and more. So that was the same thing I did for Y3 too. So continue from where I stopped. So we are going to do plus f times z. We've already done we already done f times z already. So we are just so this is f times z. So this is f times z. Sorry, because I need to rearrange the blocks. So f times z are remaining. So this plus now go all the way to join the f times z. So as you can see, f times z. So just go directly. So that means f times z plus vs. This is f times z. This line brings in f times z plus v. This signifies vs times this is y3. Sorry, vs times y3. Then vs times y3. Then lr times x1. So this is lr. This is lr. This is lr times x1. This brings this up to here. Lr times x1. Then this is lr times this is the multiplication x1. Then what is next? I've stated this on this. Then it remains 2. Then it remains ls minus minus ls times x2. So we are going to bring our ls. This is ls. This is ls. So this is ls. So we're just going to drag the line from here. So can we join our ls here? So sorry, multiplication block, drag it down, then minus. What we are trying to do is ls. This is ls times x2. So this is our x2. This is our x2. Then we are going to bring it here. I don't want to confuse anybody watching the video later on. So ls, this is our ls times x2. Then what is the next one? vr times y2. It's vr times y2. We have vr here, and we have vr here. So we don't need to create another additional block. We just need to vr times y2, and we have y2 here. We have y2 here. So we're going to another product block. Another product block, then join it here. Then this is VR. So R VR. I'm just trying to make it clear. Sorry. I'm just trying to rearrange the lines. This is VR. So this is VR. VR times. So we are trying to do VR times y2 minus VR times y2. We are trying to add it to this minus already created. That means plus, 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 minus, minus. So the minus that will be the sign in front of the product of VR times y2. So VR times multiply the y2 here. Multiply the y2, then which connect it together. So this is the second. This is the second equation. So we are going to we created our division. We've created our division block. We have our integrator block. We have our division block. So we are going to create MB first. We are going to create MB first. MB, then join it. Then this is LS times x2 plus ls times x2 minus b times x3 minus vs times y3. So we are going to an addition block, just something like this. Then here in the first equation we have like three signs. That means three additions and two subtractions. We are trying to add three things. We are trying to subtract two things. That means plus 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 then minus minus. And we are trying to like, but here we are trying to add only one thing and subtract two things. That means we are going to have we need only three of these, then one addition, then two subtraction, as this. So in the first case we have ls minus x2, ls times x2 as plus ls times x2 as our product block, join it together. This is ls trying to rearrange the blocks. So it's ls times x2 times x2 here. They are going to the same place, they are going on the same line. Then minus b times x3, then a product again. This is our b, then b times x3, as you can see, b times x3. Or we can just join it here, b times x3, then vs times y3. So we are going to look for vs. We're trying to look for our vs. So we've used our vs at the top. We are going to use our vs times, done vs times y3 at the top. So we don't need to complicate things. So we just copy we just start from this line. Um, here, sorry, vs times y3. So this particular line signifies vs times y3, vs times y3, not out vs times y3 here. So we are going to minus this vs times y3. We just bring it from here. So I'm going to delete the line so that it's not confusion. So minus vs times y3. And we know that these are vs times y3. This particular line is vs. This particular line is called vs. This particular line is vs. And this is our y3. You can see close to y3, and this particular line is vs. Because it's going to ls minus b, ls minus b, and ls is r plus f times qf, like that. So that signifies our complete equation. We've done everything here. We've done 1 over b times ls s2 minus b times x3 minus vs times y3. So that the next thing now is to add a display so that we can see our result. So we can just double tap, search for a display, then tap, right click, then drag, right click, drag, because we are trying to get 3 values. Then connect it here, connect here, then connect it here. And we are going to find our scope for graphs. For us to draw the graph scope, configuration property, three layouts, number of inputs per 3, 3, we have 3, then apply. So, so we can use one scope for 3 different values. We can use put it at the middle. Yeah, I'm just trying to add. So the next thing is to put the initial conditions as yes, we have initial conditions here, that's stated here. So the initial conditions are 0, 0.5, and 0. This is for x1. This particular one is for x1. And this particular one is for 0.5, and this particular one is for 0. So 0, and this is 0.5. I'm double clicking, and then this for 0 too. So I'm going to be inputting the values in the parameters here. I'm going to be putting them in the blocks. So this is for alpha. So this is yours of the book. Alpha is 5. I think we have to like skip this because people already know how to. Then
Not yet. I never.
3. R is 3. Sorry. This R is 3. Then we have to like pause and continue so that I can input the values and we just run it and get the values. So yeah, inputting the values, and I don't want to bore everybody with the no matter I can input the values then. Yes, then I will just come back when I'm done inputting the values and yes, I'll just share the computed values on the group. Yes.
Guys, we have to stop here. I hope you've been able to learn as much as I did. I know it seems a little bulky, but we really thank Precious for taking almost 2 hours to break down MATLAB and SIMULINK as much as he can. He said with practice, we should be able to do this in less than 30 minutes, right?
Yes.
Yes.
I'm not saying that.
Yeah, but we should just practice it, right?
Just practice.
Okay, develop from the beginning and run it by ourselves. Okay. So let us stop here today. Thank you so much, Precious Asubiaro.
Thank you so
Now you, our dad.
much.
So